Hello everyone, welcome to another quick tutorial from 3G 4G. I have to warn that this is going to be a bit long and much more technical than some of the other videos that I have done. It may be a good idea to check out some of the other 5G videos that I have done recently, especially on 5G terminology, as that lays the foundation for some of the discussions in this video. It may also be worthwhile checking out the presentation on control and user plane separation of EPC nodes, also known as CUPs. In that video, I explained that in legacy EPC architecture, some of the nodes do the control plane and user plane functions. So TDF, P gateway and S gateway does control and user plane functions. As part of CUPS architecture, they have all been separated into control and user plane functionality. Now, the network architecture that you are seeing here, you must have seen it in many of my videos and is known as the reference point network architecture. The 5G system reference point representation can be seen here. This is from the 3GPP technical specification 23501. In reality, the 5GS or the 5G system architecture will be represented as service-based architecture or SBA. We won't be viewing the network in reference point representation going forward, but it will take time for people to get used to the new service-based architecture, which is the common compute platform. Now, the common compute platform could be in the form of a databus or it could be fully distributed as well. We may want to put the functions in different parts of the network to manage different capabilities. I'm going to look at some of the at all of these entities in detail now. This slide from Georg Mayer shows the service-based architecture terminology. What is meant by network functions? So as you can see, all these different network functions, the NRF, the PCF, UDM, AF, and even the ones which are actually not listed below, the authentication, AUSF, AMF, SMF, they're all network functions, right? And you have the service-based interface on which all these network functions communicate with each other. Finally, you have the service-based architecture, which is covers all these boxes except for the AF or the application function. This is another slide showing the advantages of moving from reference point architecture to service-based architecture. So as you can probably see, and I've mentioned earlier, so when you have virtualization and slicing, softwareization, cloudification, I'm not even sure if these are words, but let's go for them. Application programming interfaces, harmonized protocols, exposure to third parties, backward and forward compatibility. All this will be enabled by the service-based interface, service-based architecture. So let's start looking at the 5G system and the service-based architecture. The 5G UE connects to the G Node B or the new radio or the next generation RAN, NG RAN. The G Node B connects to the user plane function, UPF, via the N3 interface. Now, the UPF or the user plane function in the 5G core network provides functions specific to user plane processing, the same as the serving gateway SGWU and the PDNP GWU in CUPS. Um, so the section 6.2.3 of 23.501 has more details on this functionality of UPF. Now, I'm mentioning this specification and this section in the video, but in the slides, which you can also download from SlideShare, I will provide an extract from this particular section of 23501. The user plane function connects to the data network or DN via the N6 interface. This is similar to the SGI interface in case of LTE. The session management function or SMF connects via the N4 interface to UPF. The control plane functionality has been slightly reorganized in the 5G core network. Instead of MME serving SGWC, PGWC in EPC, the functionality has been divided between session management function SMF and the access and mobility management function AMF. We will see AMF soon. There can be multiple SMFs associated with the UE, one for each slice. Now, this is an important point to remember. When we look at some of the examples later on, we will see this. And finally, the section 6.2.2 of 23501 has more details on functionality of SMF. SMF does a lot of different functionalities. So some or all of these SMF functionalities may be supported in a single instance of SMF. Remember, I mentioned that there may be multiple SMFs, right? So not all SMFs will have all different functionality. Then we have the access and mobility management function or AMF. This connects to the UE with N1 interface and G node B with the N2 interface. So AMF is a single node to manage all UE related functions. The EPC functionality of MME, SGWC and PGWC has been reallocated so that all access and mobility functions, access and mobility functionality is all done in AMF. Again, section 621 of 23501 has more details on AMF. Now, it is important to remember here that there can be a single or a set of AMFs per UE, but there is only one NAS interface instance per access network between the UE and the core network, terminated at just one of the AMFs that implements the NAS security and mobility management. So there can be uh, multiple AMFs, but only one of them will be associated with NAS signaling. And of course, there can be multiple SMFs and UPFs. We will look at the examples later on. Then we have the network slice selection function, NSSF. Now, NSSF was not there in the original architecture, but has only been introduced recently. So the NSSF supports the following functionality. Selecting the set of network slice instances serving the UE, determining the allowed NSSAI or network slice selection assistance information, and if needed, the mapping of subscribed NSSAIs, determining the AMF set to be used to serve the UE, or based on the configuration, a list of candidate AMFs, possibly by querying the NRF. Then we have the network exposure function. The network exposure function NEF has a function similar to the service capability exposure function SCEF in EPC. So network functions expose their capability. Um, so the network functions expose their capabilities and events and may be securely exposed, for example, third-party application functions, edge computing, etc. So it allows access to the shared data layer, like analytics, for example, using a standardized interface to the unified data repository. We'll see UDR in a minute. Then we have the network repository function, NRF, which offers a whole range of function like discovery function that offers software entities serving the control plane services identify other entities in the network and can connect directly when they need to. So this allows us to be very slick in how we do communication. Now, different network functions are connected together via this uniform interface called the service-based interface, which we saw before. In addition, an individual network function consists of smaller unit functions called NF services, network function services. And an NF service is in a certain NF can directly access an NF service in another NF without having to pass through another node. This is very important point to remember. So the network repository function provides a discovery function for all these network function services. Right? More details in section 626 of 23.501. Okay, so now let's look at the Unified Data Repository, UDR. So UDR is a facility where user data can be accessed, stored, and managed in a common way. Uh, section 6 to 6 to 11 of 23501 has more details on UDR. Then you have also the front end FE. So the front end is a core network functional entity or service layer entity or provisioning entity that can access user data stored in a unique repository. So a front end identifier is defined as a name that uniquely identifies an FE within the set of all FEs accessing the UDR. The combined entity with FE and UDR is known as the Unified Data Management, UDM. So UDM is analogous, remember, is analogous, not similar to the Home Subscriber Server, HSS, in the EPC architecture and introduces the concept of user data convergence that separates the user data repository, UDR, storing and managing subscriber information from the front-end processing subscriber information. Section 6 to 7 of 23501 has more details on the functionality of UDM. Then we have the authentication server function, AUSF. Now I write it here as the AUSF FE to show that this is actually a front-end functionality. The front-end section includes new specification for an authentication server function dedicated to authentication processing. There isn't really much more in detailed information in 23501 on this right now. Then we have the policy control function, PCF. The front-end section includes new specifications for the policy control function, PCF, corresponding to the policy and charging rule control function, PCRF, in EPC. And 624 of 23501 has more details on functionality of PCF. So this whole combination of UDM, AUSF and PCF is also referred to as the user data convergence, UDC. So the user data convergence is optional concept to ensure data consistency and simplify the creation of new interfaces, creation of new services by providing easy access to the user data as well as to ensure the consistency of storage and data models and to have minimum impact on traffic mechanisms, reference points and protocols of network elements. Now for this UDC, you have to refer to 23.335 because the more details on this is not available on in 23501. So this is how the UDC reference architecture looks like with the UDR and the front ends. Then we finally have the application function AF. So the application function AF fulfills the role of an application server. It interacts with the 3GPP core network in order to provide services. An application function could be something like the IMS network, which would allow us to do voice over 5G, for example, in future. So 6 to 10 of 23501 has more details on the functionality of AF. Now, it needs to be remembered here that there could be trusted and untrusted application functions. So application functions that are considered to be trusted by the operator can be allowed to interact directly with relevant network functions, while the application functions not allowed by the operator to access directly the network functions, they shall use the external exposure framework via NEF to interact with the relevant network functions. So this is the final 5G system service based architecture. So as in most pictures, the application function is actually sitting outside. So here I have modified this picture, right? Logically, it does make more sense to have it as a part of control plane function group, but because everybody is showing it outside the service based architecture, that's how I'm going to show it as well. Now, this picture is from the heavy reading white paper, and it shows how the evolved architecture with cups in EPC and the 5G system architecture look like. So I've just put it here for reference. It's an interesting picture. This is another nice picture from Ericsson presentation that shows the mapping of EPC functions into new 5G functions. Good reference to have to get the head around the 5G system. So coming back to examples, now here is an example of a 5G UE connected to the eMBB and the URLLC slice. Now as you can see here that except for the UPF and SMF, all the other entities are the same, right? So we have multiple UPFs and SMFs, but all other entities are just one. Now, we have already seen this picture earlier of the 5G system architecture in reference point representation. So here I'm just showing the green for SMF and red for UPF. Now, this is the 5G system architecture for multiple PDU sessions. Okay, so you have two SMFs and two UPFs here, right? So I've shown SMF using green and the UPF using red. Now, in this one, this is an example of concurrent access to two data networks. Example, local and central using a single PDU session option. So as you can see, you have a single SMF, but you have the multiple user plane functions. They're both connecting to the same session management function. Now this picture is from 3GPP. So I provided a reference later on. So this is the first reference in the references. But here you can see that it shows the 5G system with the network slicing. So there are multiple of AMFs, PCFs, NRFs, SMF, UPF, but only one network slice selection function, NSSF. So here are some of the references. The first reference is actually an article on the 3GPP's website, and it's a long article, but it's an interesting read. So hopefully you like this presentation. Please don't forget to like it if you really liked it, and subscribe to the channel. As always, there is a lot of information that I did not cover as a part of this presentation, but hopefully in future sessions. As always, feedbacks, comments, suggestions are welcome. Thank you.